write this in backward form. We did one like this yesterday on the homework. What would you do? First of all, how would I start this problem out?
Roughly zeros.
How would I start it off?
Get out the zeros.
Yeah.
How would I start this off?
Order Y.
Say it again.
Order pairs.
F of x
Had it written.
equals,
Zeros.
X
minus
plus
X.
5.
what would it be?
X plus 5.
Why x plus 5 if this is
Well, that's a
minus
negative.
5?
To get to zero.
Oh, it's the opposite. Very good. So this, we all agree this is negative 5. What about this one?
X plus 2.
X.
X
Minus 0.
X minus
Why'd you skip that one?
It's a fraction.
What is it?
It's a decimal.
I don't know. I don't know what this is. This one is x, we have x minus something. I'm just gonna put that as a something. And then we have x minus, right. Okay, now, see this something? This could be, I'm gonna make stuff up. It could be 1.5. It could be 1.4, 1.3. It could be 1.479238 It could be the square root of 2. What are these kinds of numbers? What's the difference between these zeros, like -5, -2, 0, and 3, versus these types of answers? Do you remember what these kinds of numbers are called? 3/2, 5/4, and what these two numbers are called? You gotta know, and if you don't know, you're gonna have a hard time with the directions today. What type of number, I heard someone say it, but not enough. Jordan, say it louder. What are these numbers called right here, over on this side?
Correct.
No, try again, it's opposite.
Rational.
These are rational. Whenever you have a decimal that terminates, or if it repeats, like 1/3, what's 1/3? 0.33333. If you have a decimal that repeats or terminates, or if you have a fraction, this is a ratio of two integers, that's a rational number. This is a rational number. So this might be a rational 0, or it might be one of these kinds, the square root of 2. It could be this. These are irrational. So, do we have a general name for all of these zeros, regardless of if it's a rational or irrational? What are all these zeros called? These are called real zeros. These are real. They're all real. But this one, this one, this one, and this one are rational zeros. And this one might be, I don't know, it might be an irrational. It might be the square root of 2. Okay, I really don't know what it is. But the instructions today are going to ask you to find, it's going to ask you to either find rational zeros, or it's going to ask you to find real zeros. Now there are some more zeros here. What this is going to generate right here, these are going to be imaginary.
Yeah.
These are the ones where you have like that,
Yes.
like that, okay? So you have to know the difference, because if I say find the rational zeros, and let's pretend like this came out to be the square root of 2. If I say, give me the rational zeros, you better only say -5, -2, 0, and 3. If I say find the real zeros, you name them all. And this is for Ashley. Ashley is leaving. Ashley, do you have to go?
I don't know, I don't think
It's
so.
Miss, oh, Woods. Miss
It
Woods.
said I was at like the beginning of 4,000, so.
It
unless
says
I go
third.
right now. Alright.
It's up to you, and it says ASAP.
Hey, they never sent faxes the hour you want.
Alright, so now, your job,
Just a second, I don't think they're out.
your job today, I need a new one, I don't know what to do with that.
Random question, can you prove .9999? That's better.
No, no, hold on. Oh, it's back here. The notes. Example 1, okay. Alright, everybody look at this problem right here. Question, example 1. You have in this packet my handwritten notes. I'm not gonna read them to you, you can go through them. I wrote them out, drew arrows, you can walk through them yourself. It's best if I do some examples with you, this is the best way you're gonna learn this stuff, okay? Now, you already did this stuff last year. And from what I understand in Algebra 2, it was in. So we're gonna do it some more this year. You have it. Everyone see example 1? Now, I want you to read example 1, and believe it or not, this is example 2. It's blotchy. What do you see different about example 1 and 2?
One's
The
the rational,
directions.
There you go. One says find the rational zeros, and this one says find the real zeros. Are they the same question?
Nope.
No, they're different answers. Are you with me? So that's why I just went over that. So the rational zeros you're gonna find are the ones like the 5 and the -5 and the 3. It could even be a half, a fourth, a third. Those are the rational zeros. The real zeros are the ones like the square root of 3, along with 5, -5, 2, 1, a half. So, we're gonna start this problem. If you had f of x equals x squared minus 9, and I asked you to find all the zeros of this, we have underneath our hat, easy ways to solve this. What kind of equation is this? What kind of equation is it? It's a quadratic. We know 5 different ways to solve quadratics. This one is an easy one. This one is a simply factorable one. So what are the zeros? They're 3 and -3. Okay? So if you get a quadratic, you can either simply factor it, if it's simply factorable. You could use the quadratic formula. Remember what that is? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. You can complete the square. And then we also talked about using a graphing calculator. We're not going to do that in this section. This is entirely from your brain. So if it's simply factorable, obviously do that. You may need to pull in one of these right here. But look at this problem. It's not x squared, it's x to the 4th. So that means, see this degree? The degree is 4. The degree of this is 4. So that means there are up to 4 possible zeros. Now, does that mean there are 4? No, there could be 1. There could be 1. You have to break this down. Now, how do you find the possible zeros? We use the rational zero test. Now, this is in your notes. What you need to do is take the constant. Everyone should know that this is your constant. I need to know all of the factors of 6. You're going to create a fraction. The factors of 6. What numbers go into 6 evenly? 1, 2. Now see how I'm writing plus or minus? 3. Does 4 go in? Nope. But 6 does. So in other words, you're going to take every number that can go into 6 evenly, which are 1 to 6, 1, 2, 3, and 6, and it's pluses and minuses. Then what you're going to do is take your leading coefficient, which is a 2, and what are the factors of 2? It's 1 and 2. You guys remember doing this last year? Yeah. Okay, now, look at this list of possible zeros. You have to come up with combinations with the numerator and the denominator. So look what we have here. We have 1. We have negative 1. We have 2. We have negative 2. We have 3. And we have negative 3. We have 6. And we have negative 6. Now we're going to go, we have 1/2. And we have negative 1/2. And now if we take these other numbers and divide them by 2, what's 2 over 2? 1. We already have it. What about 3 over 2? I'm just writing it plus or minus 3 over 2. And then what's 6 over 2? Is 3, and we already have 3. So these are our possible zeros. So what you're going to do is one at a time. You are going to use synthetic division, and you are going to take 1, negative 1, 2, negative 2, and by using synthetic division, and these are your coefficients. So let's try 1. Let's start with 1. You're going to put the number 1 out. And you're going to label, your inside here, you're going to have a 2, a 1, and you want to write small because there's not a lot of room here. Your job is to try these. When you get a 0 right here, that will be a factor. That's a 0. Okay, so you're going to bring this 2 down. 2 times 1 is 2, and now you're going to add. 3 times 1 is 3, you're going to add. You tell me when I can stop. I don't need to do this anymore. 1 does not work. It's not a 0. Now, if you want, you can try negative 1, or you can jump to 2. Now see this list? It's very long. I have 2 tests that will help you alleviate some of the agony of when the list is really long. If you try a positive number, like 1, 2, 3, 6, half, and 3/2, when this number that you're testing is positive, and all these numbers down here come out to be positive, that number was too big. So let's say we tried a 2. Let's say we tried a 2, and we came up with all positive numbers down here. That number was too big. You got to go smaller. So what that test will show you is don't try 3. Don't try 6. Cross them out. You're wasting your time. Now, what if we tried a negative number? A negative number here, and if you get opposite signs in the bottom, that number was too small. You're going the wrong direction. Try something bigger. So, I'll say it again. If this number is a positive number that you're testing, and all these come out to be positive, that number is called an upper bound. It's too big. Don't try anything bigger, cross them out. Go the other way. If you try a negative number, and you get checkerboard positive, negative, or negative, positive all the way down here, that number's too small. That's a lower bound. try something bigger. If you look in your notes, I wrote it out for you right here. There's a hint, you go through it, and I show you here. So when you're trying a positive number, and you get all positive numbers here, that's an upper bound. Try something smaller, go the other direction. If you try a negative number and you get opposite signs, so negative, positive, or positive, negative, then that is a lower bound, try something bigger. Okay, so keep that in mind. So, we don't know, one didn't work, but this is not an upper bound because of these negatives. So let's go to 2. We're gonna put 2, 1, negative 17, negative 4, and 6. Bring down the 2, and let's do synthetic division. 2 times 2 is 4, and you get 5, multiply 10, negative 7, negative 14. And what's happening, this is just getting, it's not gonna work. I'm gonna stop. Let's try 3. So 2 didn't work. Let's try 3. So we have 2, 1, negative 17, negative 4, and 6. Bring down the 2. 3 times 2 is 6, add. 21, 4, what's happening here? Too big. So 3 doesn't work. But look at this. Look at this. What do you notice? 2, 7, 4, 8. This is going to be 24. What do you notice about 3? We're using a positive number, and all these are positive. So what is 3? 3 didn't work. So guess what? 6 isn't going to work either because it's an upper bound. So what do I need to do? I need to try some other numbers. I need to try something smaller than a 3. Okay, what are numbers smaller than 3? Don't do negative 1. Jordan said don't do negative 1.
Half and 3.
Does negative 3 work?
Yes.
Let's just skip to the chase and do it. Okay, so we're going to try negative 3. Bring down the 2, multiply, add, multiply, add, multiply, add, multiply, and add. Yay, that's what you want right there. You want a 0. So, negative 3 is a 0. Now, how will you write this in factored form? You're going to write x plus 3. Very good, x plus 3. Now, what are these numbers right here? These are the coefficients 1 degree less than 4. So it's going to be 2x cubed minus 5x squared minus 2x plus 2. Now we have to start over. Now, do I want to use this list of zeros? No. Because look at this number and this number. These possible zeros, so if you did the rational zero test here, the RZT test, you would get plus or minus 1, plus or minus 2, over plus or minus 1, plus or minus 2. See, the factors of 2 over the factors of 2. So, look at this list. What numbers are we talking about? We're talking about 1, negative 1, 2, negative 2, and we're also talking about a half and negative a half. Now watch this is kind of cool. See, these are the possible zeros. If 1 and 2 did not work here, they will not work here either. So you can cross 1 and 2 out. So look at the numbers that are left for us to choose from. What do you want to do? You want to try negative 2? Let's try negative 2. So I'm running out of room, so I need paper. So we're going to try, Jordan wants to use negative 2. Now you're going to put a negative 2 out here, and you're gonna put a 2, a -5, -2, and 2. Bring down the 2, -4, don't do it, he's already telling us, don't do it. It's too big. And look what this is. This is a lower bound. See the checkerboard? See your positive, negative, positive, negative? When you try a negative number and you get this check, that's too big. We have to try something smaller. Well, what's smaller? Let's try one of these fractions. Let's try a half. Don't be scared of these numbers. 1/2. Let's try 1/2. 2, -5, -2, and 2. Bring down the 2. What's 1/2 times 2? 1. Add these up. What's 1/2 times -4? Add these up. And what's 1/2 times -4? And there you go. So what we have, we want to keep a running total here. So 1/2 worked. So what you have is x plus 3, x minus 1/2, and then what's left here?
2x squared.
2x squared minus 4x, and then minus 4. Now, when you get to this point, you have an x squared. Use the quadratic formula. Can I take anything out of this? A 2. Let's take a 2 out. If you pull a 2 out, you got that. Now, can you simply factor this? No. You cannot simply factor this, because I don't know what times what is -2, but adds to be -2. So now what we have to do is do the quadratic formula. Yep, a lot of work. Mm-hmm. There will be one in only one of these. So, the opposite of -2 is 2. -2 squared is 4. A is 1 and C is -2. And then 2 times 1 is 2. Now let's simplify this. 2 plus or minus the square root of 4 plus 8 is 12. And then how do you simplify this? It's 2 root 3. And how do you further simplify it? 1, 1, 1. So it's 1 plus or minus root 3. Could I have gotten this answer doing it a different way? Yes. I could have completed the square. How do you complete the square? What do you do with this -2? Bring it over to the other side. Then do you remember what to do? You take half of -2, which is -1, and square it. Remember, you add that number to both sides. So you get x, factor this, x minus 1 squared equals 3. Remember what to do next? I think completing the square is easier than the quadratic in some cases when this is an even number. And then add 1. Now, to me, that was a lot shorter than doing this quadratic formula. But look at that, you get the same answer. Now, let's answer our question 1 and 2. What kind of answers are these? Are these rational? Are they real? These are real. When are they not real? When are they not real? When there's a negative under the radical. Those are not real. But these 2 zeros, well, these are the same. These 2 zeros are irrational. So let's answer our question. It says for number 1, example 1, it says find all the rational zeros. What are you going to say are your rational zeros for this answer? What are they? What are the rational zeros? -3 worked, and 1/2 worked. These are rational zeros. You can write x equals -3, x equals 1/2. But look at this question, number 2. How would you have answered this one? Find all the real zeros. I'm not going to go through and do this problem again because it's the same problem. The difference is you're going to list these 2 zeros in this answer along with -3, 1/2, and 1 plus or minus √3. There's 4 zeros here. There's up to 4 zeros. It's just a matter of, do they want the rational zeros or do they want the real zeros? These are 2 different answers. Does everyone understand this? Okay, so let's look at this question right here. This one says factor this completely. Now, because today's a Wednesday and we don't have much time, if I asked you that question for this one, factor this completely, what would you write for an answer? Remember, these are your zeros. What would you write?
X plus 3,
X plus 3, so far so good.
X minus 10. And then, isn't that the one that we did the weird?
Yep, you did these on the last test. You're gonna write X minus 1 plus the square root of 3. And you're gonna write X minus 1 minus the square root of 3. This is factored completely. Notice how it's always the opposite of the zeros. So what are your zeros? -3, 1/2, 1 plus √3, and 1 minus √3. Okay? Questions? How much time do I have? I have to move it.
6 minutes.
I don't have much time. Skip, go look at number 15 on the homework. Look at number 15. I've got some tricks for you. Look at this problem for a second. What's our constant? Is it 0? Is it 0?
0.
No, it's not. It's not going to be 0. Why is it 6?
Oh, you have to take out all the.
You want to pull, you always need a constant here. You're going to pull this, we have x to the 3rd common here. You guys remember this?
Yeah.
So we've got three of our zeros accounted for, which is 0. So one of the zeros so far is 0, right here. Now, there's 3 more we gotta find right here. So what are you gonna do? You're gonna try factors of 6. Over factors of 1, which you know will end up being just these numbers. So when you try this one, try 1, try 2, use your upper and lower bound. When you find your first 0, when you hunt down, you find your first 0, you're going to end up with x squared. Whatever you get in your bottom row, it's going to be x squared. Then you're going to use the quadratic formula to find the other ones. Now read the directions in this. It says factor the polynomial. So they want it in factored form. They're not you need to find the zeros to get it in factored form, but you need to do what we just did on that last example. Okay? Skip to 7 or 9 or 11. We're gonna set 7 up. What's wrong with 7? To give you a hint. mess with those.
Rational zero.
But what, look at the problem, 1/12 x cubed minus 1/12 x squared minus 2/3 x plus 1.
They don't all have common denominators?
Let's get rid of the fraction. What are you gonna do? Multiply everything by 12. So we're gonna get rid of these fractions. We're gonna multiply everything in here by 12, and then we're gonna do the problem. What about this one, number 9? What would you multiply everything by? 3. And what would you do for 11? Move that over 1, move this over 1. So in other words, this is gonna be x to the third minus 19x, yuck, plus 30. We don't like when those numbers are big. For this one, when you do synthetic division, a lot of times it's 1 or 2. They don't usually give you crazy answers, but your possible zeros are 1, 2, this list is gonna be crazy, 3, 5, 6, 15, oh, 10, yeah, 10, 15, and 30. Those are your possible zeros. Hopefully, when you get to like something like if you got to 3 and it was an upper bound, you don't want to try the 6, the 10, the 15, and the 30 and cross them out. But when you do synthetic division, this is going to mess some of you guys up. How would you start it? 1? Very good. That's what I wanted to get at. You need a 0 here. No, I always start with 1 and work my way that way, because sometimes you'll find an upper bound, and then you don't have to try the bigger numbers. I start at 1, when I find my upper bound, then I go backwards to the -1, and then find the lower bound, and then chop a lot of answers out.
What? No, it's,
No, that one, you know if the 1's not gonna work.
so I got the Cokes.
Try 2. Try 2. You might wanna try 2.
Oh my gosh.
And
it
look at
worked.
that.
Hey,
Look at it.
it worked.
Am I
Oh
good or
God.
what? So look what you have now, wasn't that bad? X minus 2, what's this? X squared plus 2x minus 15. Can you factor this?
Yes.
What